Okay, this is a set of notes for March 12th. I'm doing this in my alter ego rewindable herald. So what we got here, it's a collection of questions which can be answered using the Super Bowl commercials data set. In this work-along format, I'm just going to talk straight through, but at some points I will tell you to stop, pause, and try to do the problem yourself before you look at my solution. And to get the most out of this set of notes, it's important that you take my advice to stop and work on it before you look at the solution. Okay? So the first part, we'll just load the data and get the libraries we need. And here's the command we copied from Tidy Tuesday to get that data. And then, of course, we need the library verse. We need the library, the tidyverse. And then we'll glimpse YouTube just to remind ourselves of what the variables are in this data frame. Okay. And so the first question, I guess, relates to success. And for our purposes, we'll consider popularity as the criterion of success. Of course, from the point of view of the company that created these ads, the real definition of success is that it improved the company's sales. But we can't tell that from the data we've got. All that we've got is to assess popularity on the basis of the number of views and likes and dislikes. So the first thing we'll look at is view count. And the idea is that a higher number of views means that an ad was more popular. Of course, you have the obvious problem that an ad that has been out there for 10 years has had more time to rack up views than an ad which was just produced in the last year. So we have to ask the question, is view count correlated with year? Okay, so this is the first point where I'll say stop. Don't look at what I did. Go ahead and try this yourself, okay? See if you can examine the relationship between view count and year. Okay, you're back. I assume that you've done the work. So the way we're going to do it, we'll take YouTube, and then we're going to do a scatter plot of year and viewpoint using the standard setup. In our aesthetic, year goes on the x-axis, view count goes on the y-axis, and the geom is point, and the geom_smooth is LM, so that we fit a linear model, and we see that, oh shoot, this looks like junk. What's happened is we've got this one outlying observation. Sometime we'll have to take a look and see what this is that got more than 10 to the 8th views. But what happens when the graph has to incorporate this point up here, then all the data down here, most of the data just gets compressed almost into a single line. Only these 3 points stand up as being anything different. You can't see anything this way. So the standard solution to do that is to put a scale on the y-axis. We'll use a logarithmic scale. Okay. And do a little bit of research at this point. To figure out how to do that, just Google for ggplot scale logarithm, okay? And when you're done, come back and look at the way I've done it. You've stopped the video, right? Okay, you're back. So I assume you figured out how to do this and you fiddled around and you've done it. Let's see the way it's done. All you do is take the same code that you had before and then add scale under y_log10. Now let's look at it. And here we see the data spread out, and you notice that this point right here has been brought an awful lot closer. In fact, what's happened is that it's got a value a little above 8, whereas down here you have a value a little above. This value is exactly 6. So, but it's showing the data on the raw, showing the values on the raw scale, but the actual positioning of things is logarithmic. Okay, so now we can see, and the method equal LM allows you to look at the slope of the overall cloud of points, and we can see that it doesn't really, well, if anything, more recent ads have higher views. So we don't have to worry about the ads coming from back here in 2000 that have been viewable for 20 years, that they should have been able to rack up more views. But they didn't. Okay, so there's not a bias in favor of older ads. Another possibility for measuring success is the ratio of likes to the sum of likes and dislikes. Create this variable and see if it is correlated with view count. Okay, again, stop the video, do the work, then come back when you're done and look at what I've done. If you just go look right now at what I've done, you're not going to get anything out of this exercise. Okay, you're back. I assume you've done the work. And I'll call this variable fav, and I'll create it, of course, with a mutate. It's like count divided by the sum of like count plus dislike count. And then I do the standard scatter plot, look at the relationship between fav and view count. And of course, every time I use view count, I have to remember that it has such a weird outlying data point that I've got to scale that axis. Okay, so let's take a look at it. Look at our results. And well, one thing, if there is any relationship here, it's definitely downward, but I'm concerned by the large number of values where I had a favorability rating of, it looks like exactly 1, which means that I had some likes, but I didn't have enough dislikes to make anything look different. You realize that this could happen if you had only a single like, only one like, and this is 0, then you would have a favorability rating of 1. So what I want to do, I want to limit the data to require a minimal number of likes and dislikes. And you can fiddle around a little bit, but you're going to put a filter command in your pipeline to make sure that you don't accept any favorability values that are based on only 1 or 2 observations. Okay? So go ahead, stop the video, do that, then come back and start the video again. Okay, you're back. I assume you've done the work, and after a few trials I decided that I would base my filter on requiring that the sum of the like count and the dislike count be greater than 100. And then I did the same thing as before. Didn't change anything. I noticed that I got rid of all of those values that were exactly 1, and apparently the reason why they were exactly 1 is that there was really very little data, but it was heavily in favor of like. But same conclusion, there's a negative relationship between these 2 potential measures of success. So we're going to proceed with view count as our selected measure. Okay, the obvious question is which characteristics lead to a higher count? And what we want to do next is look at each of the following in turn using side-by-side box plots. And funny, patriotic, celebrity, danger, animals, use sex. Those are the things that we think might influence the popularity of a characteristic, make it more popular. So go ahead, do side-by-side box plots for each of those variables. Every one of these variables just simply has the value of true or false. Okay, you've stopped the video, you're doing your work. Come back when you're done, and I'll show you my side-by-side box plots. Okay, you're back. Let's take a look. Here's the box plot for funny. So on the aesthetics, put the logical variable funny on the x-axis, and on the y-axis we have view plot, view count, and the geom is box plot, and again I scale the y-axis because of the extreme variability. Here's the box plot for funny. No, I can't see anything there. It looks to me like there's no tendency for true to be better than false, maybe just a tiny little bit. Okay, what about patriotic? Here's the box plot for patriotic. Well, kind of could be, but it's the median here is greater than the median here, but it's spread out, and this has some high outliers. I don't know. Celebrity. Nah, nothing there. Animals. No, nothing there. Danger. Well, maybe, yeah, it looks like maybe there could kind of be something there. Sex always sells, right? Doesn't look like it. Looks like the median view count for things involving sex is even below the median view count for things that don't involve sex. So the only thing I saw that looks kind of promising is danger. Another approach to this, I know that this is something that you really probably haven't studied yet, because we're going to include multiple variables in a linear model. And okay, we'll just go ahead and look at that, because I know you don't quite know how to do it yet. We'll take this up later in the course when we get into modeling at the end. So I'm going to create a linear model. The dependent variable will be the log 10 of view count, tilde, and then I follow with a list of the independent variables separated by the plus sign. And it's just all of those logical variables that we had, which in the linear model, this will be treated as just 0, 1 values. Okay, so here they are. So if funny is true, it says the estimate is that would increase the log to the base 10 by about 0.23. But you look over here and you see, are any of these things worth anything? Are they significant at all? You'll always get some value for the estimated coefficient, but you have to ask yourself, is what I'm looking at just simply random fluctuation? And the approach to that in statistics is to say, well, what is the probability if there were really nothing there, if the true value of the coefficient is true, what's the probability that I would be seeing something this big? And the answer is, well, about 25% of the time. Okay? And you also judge that by looking at the t-statistic. We look at a t-statistic of 2 with the, well, of course, with the right sign. Nothing comes up to 2. Okay, so nothing actually meets the standard beauty standard for a significant coefficient in the model. Closest you come is danger with a 1.5. And then we have 2 which have a negative coefficient, which says that using either animals or sex tends to reduce your view count, but their t-statistics are indication of insignificance. So it apparently, I would say that the truth is that neither animals nor sex have any influence on the view count, but just because something shows up, it can show up because of random fluctuation. And you can see the t-values are way below an absolute value of 2. Okay. So the next question, we've got all sorts of different types. And I'd like to combine all of the individual logical variables into a single string. Okay, so this will probably take you a little bit more time. You'll have to think about how to do this, and then you'll have to do it. Okay, so again, stop the video, and this time it may mean stop the video for an hour or so, and think about how you would get a single string which combines all of the characteristics of an ad. Okay, so go ahead, stop, maybe come back in a week. Okay, you're back. Either you did it or you gave up. Well, here's the way I did it. It's kind of a complicated mutate. There are many steps within a single mutate. I start off by setting contype equal to an empty string. And then there's an if-else. Remember that all these variables, funny, patriotic, etc., are logical values. So funny is a logical expression by itself. So if it's true, then you take the first option, which is this, which is you paste the string funny onto contype. And if it's not true, then you just leave contype as it was. Okay? So when you get finished with this, all of the things for all of the ads for which the logical variable funny was true will have the string funny added to the consolidated type string. And then you do the same thing with patriotic, celebrity, danger, animals, news, sex. And finally, if you have an ad which didn't contain any of the above, if the contype, when you're done with everything above, is still just the empty string, then you make the consolidated type none. Okay? So I'm testing this to make sure it worked. So I take YouTube, select contype, and then take the head of 10, and you can see that the first 10, the first thing turned out to have no characteristics. And the second ad had funny, celebrity, and danger. And you can see, yeah, this code is working. Okay? So let's go on and do something else. Well, what's the most common contype? So what I want you to do is use group by and summarize to get a count of contype values and display the top 10 in descending order. Okay, so we've reached that point again where I say stop the video, do the work, and come back when you're done. Okay, you're back. So here it is. Start with YouTube and then group by contype, summarize, create a variable called count, which is the n of, that is the count of things for that particular value, and then ungroup, and then arrange descending count. Okay? So we have the most common is funny with 32 values, just funny by itself. Funny with danger, 19 values. Funny with danger and animals, 16 values. And then none is actually fairly common with 15 values. And you can see funny happens quite a lot. You got 1, 2, 3, 4, 5, 6, 7 of the top 10 consolidated types contain funny. Okay? Brands. Which brands are the most common in these ads? And to look at that, I'd like you to create a bar plot of ads by brand. And which brands have the most ads? That's the question we're pursuing. So again, this is a pretty simple, straightforward one. Stop the video, take 5-10 minutes to do this, and come back and look at it. Okay? Okay, you're back. Very simple. YouTube, ggplot. The aesthetic just maps the variable brand to the x-axis visually, and then geom_bar. And you can see it really leaps out at you. The big ones, Bud Light and Budweiser. And gosh, if you combine Bud Light and Budweiser into just plain Bud, which I would be inclined to do, it's like there are more than 60, more than 40. We only had 240 observations, so looks like something like 110 of the 240 are coming from Budweiser or Anheuser-Busch. Pepsi has quite a few. Coke, so you could say alcoholic beverages, soft drinks, Coke and Pepsi. Then there's cars, Hyundai, Kia, and Toyota. A couple oddball things, the National Football League itself and E-Trade. Okay, so that's the end of this little work-along lecture, and I hope you enjoyed it. I hope you did a lot of work along the way, okay?